We'll start with the day one. So day one is basically we'll start with the course overview, what you can expect from the 7 day session of an NLP interview prep season. So then we'll move into the current task of an NLP which is used in the industry right now. Then we'll dive into the NLP pipeline, the steps which we follow to an NLP process. Then we'll move into the text pre-processing. So today's task is like we'll look into the every different text pre-processing steps which is involved in the NLP pipeline. So each and every day we are trying to have the continuation of the previous day as well as the last or subsequent days materials. So as a course review, what you can expect is like this course is planned to be a 7 days course, and this course is planned for the beginners who don't have any idea about NLP and how to start an NLP and how to do some projects in NLP for their portfolio kind of things. So this course is crafted for them in a such a way that they can understand from the beginning. So as a day one or today, we'll try to see some of the basics of an NLP, and we'll see some of the pipeline steps and some of the process of an NLP. Then on the next days, like a day two, we are trying to see how we can do the representation of the feature of the for the NLP, like a text representation factor for an NLP. It's like a jargon kind of terms. We'll figure out what to do and when to do and where to do kind of things, and we see some machine learning techniques for an NLP, how the machine learning model is going to work for any NLP task. So we'll see in the day two. In the day three, we directly deep dive into the deep learning architectures for an NLP. We try to see an RNN kind of things. We try to see transformers, BERT, and different RNN, different deep learning architectures for an NLP. So on day four and day five is going to revolve on those kind of topics. And in the day six, we move into the sentence transformers and some task in NLP related to the deep learning architecture, which is currently used in the industry day by day, day to day. So we'll try to do some tasks in the mean days. We'll also try to work on some projects which we're trying to explore in the course, and we'll try to make some portfolio kind of projects and hands-on coding during the session. So in the day seven, we move into the LLMs, like large language models. Like we I think many of us came around ChatGPT, Bard, so different kind of an LLM model. So those kind of LLM model are considered to be a closed source. We don't have any access to it. If you want to use any of their APIs, we need to pay them. So instead of using a closed source model, we come to the open source model. We try to use open source model like Mistral, Falcon, Meta, like Falcon, and then there's an Llama, it's a Meta based product. So we try to explore those kind of an LLMs, and we'll have some ideas about what they are trying to convey, and we'll also work on some like a mini hands-on coding session on the LLM part. So we'll try to do it on the day seven. So in this course, after the completion of the course, you'll be given two assignments. So one assignments will be regarding to the day three and day four, like up to whatever we covered till day four, you will have one assignment, and day five, day six, day seven merged together, we will be having another set of an assignment. So these two assignments are like pretty similar to crack, like pretty easy to crack. So those people who try to crack those kind of an assignment will be provided the certificates. Like it's like a kind of toy building problem or something like that. So we will try to send the assignments like after the day five. For the first assignment, we'll send it on day five. You have like a 15 days time to work it on our assignments, because we have a buffer time of 15 days. So within 15 days, you try to submit your solution. We'll try to evaluate the solution, and we try to accommodate the certificates for you in the best way. So this is how the course is trying to plan for you guys. The next thing which I need to convey is don't worry, this course is crafted for the beginners. If you're beginners and you don't know anything in the machine learning or any domain, it's a good place to start. You can explore on some properties, some concepts. And guys, one more thing, this course will not cover entire NLP syllabus. It covers most of the NLP syllabus which you need to for any interview process. So we'll try to to tackle those kind of problems. What we plan to do is we plan to introduce some course materials, like extra materials and extra code book and code notebooks. We'll try to share those kind of things, because everything we cannot able to accommodate in 7 days, right? So we plan for those kind of things. We'll share the links for the Notion page, which will be, I think, that will be ready within the class over. So we'll try to share those Notion page, from the Notion page where you can access to those kind of contents. So coming back to this day one, we look into the NLP task, whatever the NLP task in the current. And first, looking into the NLP task, first we need to know what is an NLP and why do we need an NLP. Okay, so everyone is going to say NLP is a software which is going to enable computer to understand blah 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 blah. Okay, well, why do we need NLP, right? NLP we call it as natural language processing. Why do we need an NLP? So the main task is like we can easily communicate with each other, because I can easily communicate with each other, because we need to translate with each other, and we can easily communicate through the medium of speech. Like I am speaking in English to you, and you can also respond me back in my known language. So how we can able to communicate with the machines, and how we can make the machine to understand our own languages. So that is what the bucket problem for an NLP. So that those kind of problem, like understanding of your context of the words, so those kind of things is going to fall under the NLP. So we need to make a model, or we need to make a mission which is going to understand the text, or which is going to understand your language. So that is what we are trying to build in the NLP missions. Okay, so the NLP is another thing which you need to think it of. Like we cannot able to build a model which can understand the single text or single word. Let us say there is a word called sad. If there is a word called sad, you cannot say that the person is sad, because because let us say I'm giving you a paragraph like yesterday I was sad, but today I was very happy. It doesn't mean that today I'm very sad, because that sad word is going to talk about the previous day, but not the current day. You need to understand the context of the word. So, for a better example, which I need to give you for this particular thing is, let us say I saw a man with a telescope in the hill. So, this particular sentence is going to have a two different meaning. I saw the man who is carrying the telescope. That is one meaning. And another meaning is I saw the man in the mountain using a telescope. I have a telescope, and with the help of the telescope, I saw the man in the hill. That is one meaning. And another meaning is I saw the man who is carrying the telescope. You need to understand the context of the word which you're trying to focus on. So those kind of things will come under the ambiguity kind of things. Like we try to explore what are the problems in NLP and how the architectures are designed in order to overcome those kind of problems. That is also we cover in the following course. Now, next we moving into the three different things. One is not three different things, same things like A versus ML versus NLP. Okay, so in the A, what we trying to do is we trying to teach our model, or we trying to teach our system to be intelligent. So that is what the A comes. So A is like a grandfather kind of things. Within A, you are going to have an ML. What is an ML? ML is like a machine learning. Machine learning is going to teach your model to be intelligent. How the model is going to be intelligent? The model is going to train on the different set of data, or different set of data points. With the help of the previous set of data or experience, the model is trying to be an intelligent or trying to mimic those kind of characters. Then what is an NLP? So NLP is NLP is a combination of your ML techniques. Like you train your model, you're going to train your model in order to understand the context of the word. Like instead of understanding the meaning, instead of understanding your data or experience, you need to train the model in such a way that your model is going to understand the context of the word, or the model is going to understand the language which you are trying to convey. So that is what your NLP is going to come. So this is the beautiful diagram which you can able to imagine, like how how NLP is comprised of ML and AI. So it's a kind of A is like a core thing, and inside the A you have ML. ML is like a machine learning, and you have an NLP. So in this NLP, you teach as a system to be intelligent by learning from an experience. Not only from experience, you need to understand the human language, or the language which you are trying to fit to the missions, like the context of a thing. So that is what the AML, ML, and NLP work together. Then we're going to divide the NLP into two different categories. If you're trying to work on any industry level projects or something, your NLP is going to divide into two different structures. So what is the first structure is like it's a natural language understanding. Next one is like a natural language generation. Okay, what is meant by natural language understanding? Okay, so let us say I am building a model called sentiment analysis. I need to understand the whole text in order to give my label. So sentiment analysis is a kind of problem which is going to have a two set of a label in the sense two set of an output. One is going to be positive, another going to be sad or negative. So you can imagine like that one. So now let us say I have a sentence, let us say, is going to talk about something related to current economic trend. So let us say we have some taken certain amount of an example of the data, like a stock market is going to crash tomorrow. So the people will lost most huge amount of funds or huge amount of monies. So you're going to have a two different set of a data. So let us say I have a two different set of an context thing. Let us say first sentence is going to talk about, let us say my stock market is going to crash tomorrow. I'm going to lose all the set of funds and related things. So this sentence something negative. It's going to convey some negative meaning. And another sentence says that I'm very happy because I have I won like a lottery, or I won some lottery or some prize in any competition. This sentence is going to talk about positive manner. In order to classify whether the sentence is going to be a positive or negative, we need to understand what the context is, what the text is. So that kind of problems will come under the category of natural language understanding. So the another domain is natural language generation. So natural language generation, you can imagine like we all use like an LLMs, right? Not LLMs. We have used like ChatGPT, right? So you will give a prompt. What is the prompt? Prompt is nothing but you give some question to the ChatGPT, and ChatGPT model is trying to explain those type of a contents or something like that. So those kind of things is kind of referred to the natural language generation, because you are generating something based on the question you're given. So that kind of things is called as natural language generation. So natural language generation, one of the example which you can imagine as right now is like a question answering pair. So let us say I'm asking some question and the model is going to generate some answer. So question answer pair is kind of problem which you're going to focus on NLG. So there is natural language generation. There are multiple problems, but I'm telling some of the basic problems of NLU and NLG. So now we are going to look into the what are the NLP tasks which are going to look at in the day-to-day life. Like, okay, so what are the tasks we are currently looking in NLP in day-to-day? So first the task is like a sentiment analysis. Okay, so sentiment analysis, where the sentiment analysis is used in a real time. Let me give you a beautiful example. Each and every big MNC company or any teams, like any football team or any cricket team or any franchise, is going to have a brand ambassadors or something called as marketing manager, something like that. Those kind of people. So those kind of people, their job is to understand how the product is reaching towards the market, how the products can able to generate a revenue to the company. Those kind of stuffs they are really interested in. But nowadays, let us say if I post something in Instagram or any social media forums, I cannot keep track of all the comments, because there is millions of people is using those kind of products, and millions of people is going to give the customer feedback or customer things or whatever they feel about the product. They're going to just put it away there. I cannot able to process all those kind of text, but I need to know what went wrong, because so there is a certain amount of people who might be really like those kind of products, but there is a certain people who doesn't really like the product much. They have some amount of like dissatisfaction. They express in terms of some words, right? I cannot able to go through all the people who posted the feedback in the customer in any online forum, right? So what I'm going to do is I'm going to build a model. That particular model is going to process all the text which are generating in the online forums or any social media platform. So that particular thing is going to classify, okay, this comment is related to the positive statement and this comment is related to the negative statement. Now I can divide my social media team into two set of people. Like one team is going to take care of the positive reviews, and another team is going to take care of my negative reviews. So once the negative reviews, my model is going to predict that particular comment is going to be negative kind of sentence. So that particular comments or that particular review is going to handle by the negative comment team. So that particular team is going to revert, okay, this place that went failure, okay, I need to improve my product, I need to improve my branding, so that I can generate certain amount of revenue to my business models, like that. So this is one of the real beautiful example for the sentiment analysis, where a brand marketing or any marketing methods which you're going to use, like it's a sentiment analysis kind of things, because I cannot able to leave all the negative comments, because that might like will make my product to be not great, because we have too much amount of PS in the market, right? So that is what we will be doing in the sentiment analysis. So next one is a mission translation. Okay, what is mission
Excuse
translation?
me, bro. I just have a doubt, if you don't mind.
Yeah.
Yeah. We talked about sentiment analysis, right? So,
Yeah.
um, uh, as far as the reviews are concerned, even the bad reviews have a scale, right? There'll be like okay, bad, very bad, terrible.
Mm.
So our
Mm.
NLP, does it have some sort of way to like categorize them, something like that,
Yeah.
by the degree
Yeah.
of
Yeah.
bad,
Yeah.
so to say?
Yeah. You will be having a degree of, for example, if you use a logistic regression. So logistic regression is like a mathematical modeling technique which is going to give the values between 0 and 1. So you can have a scale in which you can able to convert the particular range to the 3 or 4 or 5. You can have an option to convert those kind of things that we will be seeing in the modeling techniques. Okay, next one is like a mission translation task. So what is mission translation task is all about, right? Let us say we have a Google translator, right? So how the Google translator is going to work? Let us say I'm stuck in some place. I don't know Hindi, but I need to communicate with the person who know only Hindi. So at that point of time, I need a Google translator or any translation app where I will be giving some sentence in English. That particular model is going to convert the English into the any source language which we're going to give. So those kind of things is like a mission translation task. So how Google Translator works, we will see on the day 3, I guess, or not day 3. Yeah, day 3. So we'll see sequence to sequence problem modeling. So that is a problem which we are going to solve on that particular class, like a mission translation, how the Google Translator works, and how we able to translate from one language to another language with some amount of a data. So that is what we're trying to deal with, mission translation. Next one is here like a name entity recognition. Okay, let us say name entity recognition. So this name entity recognition, okay, fine. Now what happen means, like if you're working in any industry or any customer support side or any product based companies, you will be getting some amount of tokens or any get some amount of reviews or any some amount of issues. So those kind of issues need to be tagged. For example, there is something called okay, so you're working on some industry. Let us say there is some company called X. So you're working on company X. That company is going to work on 3 different products. One product they are producing is like a one product they are producing is a cricket bat, and another one is like they are working on a cricket shoes, and another one they are working on a they're working on like any sports material. They're working on one division of people is going to work on a cricket bat manufacturing, and another set of people is going to work on your shoes manufacturing, and another part of the people is going to work on JC manufacturing. So these 3 people are working on 3 different parts, but they are in the same company. Let us say there is some tokens. Tokens means there is some issues arises. Let us say the issues arise like we'll have only the context, doesn't have anything related to where they are, what problem they are facing. They don't have anything related to, let us say, this is going to talk about football, this is going to talk about shoes, this is going to talk about jerseys, this is going to talk about something called a bat. So they don't have anything. So you need to develop a system. That particular system is going to classify, okay, this is going to talk about shoes, okay, I need to give this particular comment to the those kind of peoples, and I need to extract the name from the comment, and I need to extract the location from the text where it came, and I need to extract the terms related to quantities. It's a kind of pattern matching. So you can imagine name entity recognition as a kind of pattern matching. So you're going to extract all the name important details and marks and anything that is called as name entity recognition. For example, another one example use case is like, let us say you're studying in a university, right? So for example, you're going to build a system that is going to scan your answer sheet. That particular answer sheet, in the first page, you're going to have your name, roll number, department, and what grade you're getting, those kind of steps, right? So it's going to recognize all these kind of things and going to produce as a metadata or meta information. So that kind of the problem is called as name entity recognition. Next one is like spam detection. Okay, spam detection is another use case where the industry is like using. So we all have a Gmail account and iMessage apps, and we also have an Outlook and any different messaging apps, right? So you have an inbuilt algorithm. So that particular inbuilt algorithm is going to classify your mails into the two different things. One is like a spam, another one is an ham. So ham is going to come in your focused inbox or your main inbox, and spam messages will move into the spam folder automatically. So how the system is trying to build on, and how the system is trying to make those kind of a classification, that is what we are going to. So in today's class, we are going to work on something related to spam classification, like a pre-processing for spam classification. So today's we try to work on spam classification pre-processing, and tomorrow we are going to build a machine learning algorithm for the spam classification. How it's going to detect the spam, and it's going to filtering those kind of messages. So this is spam detection is another NLP task. So next one is like a topic modeling. So topic modeling, you also imagine something to the data mining kind of things, where you're going to extract the topics from the certain amount of documents. Let us see, I have 50 documents. So in the 50 documents, I cannot able to read the whole set of documents, right? I need to get something related to what this document is talking about. So I need to have a model. I need to have a topic for that particular document. Let us say I'm searching for another example is like I'm searching for something related to AI. I need to get all the research paper out of it. Like I have a set of bunch of research paper, but I need to model it, right? So this is going to talk about something related to reinforcement planning. This is going to talk something related to artificial neural network. This is going to talk about something related to NLP, right? So I need to model each and every document. I need to model the topic of the each and every document. So that kind of problems will came under the category of topic modeling. So you have a LDA for topic modeling, those kind of algorithms which you'll try to see. Next one is like energy. Energy I already told, like a text generation. So on the day 7, we try to use open source model to generate text. So and we in a day 4 we are always try to see how to auto complete those kind of sentences, because auto complete, right? So if you're trying something, you have an option to press tab in order to complete those kind of sentence, right? So that is an auto complete task. And another one is your chatbot. So chatbot basically is going to have like a user query and is going to respond back to the content. Sorry, there is a typo here, that is p gloats, like, okay, so ignore this kind of thing. So we will upload the correct one. So there is something autocomplete, and we will be working on a chatbot in case of natural language generation kind of things. So next one is like a information retrieval. So I need to get the most relevant documents. If I search in any Google engine or any queries, like if I put some certain amount of queries, I need to get the relevant information. Otherwise, your product will be failed. Because if I talk something not related to NLP, you won't listen, right? Because you have in mind that this goes related to NLP, and I need to talk only things which is related to NLP. So in the same fashion or same manner, whenever I try to search something, I need to get the relevant information. So that kind of thing we call it as an information retrieval. Based on the information which you are going to prompt it, I need to get the documents, or I need to get an output related to those kind of context which I talked about. So that is what we call it as an information retrieval. Next one is like a summarization part. So summarization part is like we have a huge set of paragraph, and we don't have a time to read those kind of paragraph, and we don't understand certain things in the paragraph, which we try to summarize them into the smaller chunks. So that is what we call it as a summarization. There is a two types. One is an extractive and abstractive one. We look into the details in future, like what is an extractive and what is an abstractive, and how can we do those kind of things. So next one is like a question answering kind of things. So question answering kind of things basically, for example, if you take an IRCTC application, the IRCTC application, I think they have the chatbot called Dijkstra or something kind of thing. So where you'll be answering certain amount of a question, and that particular question will have a pre-defined prompts and pre-defined answers. So they're trying to fix those kind of things. That is a question answering kind of part. So these are the some of the tasks which we came in day-to-day life in NLP, right? So nowadays like NLP is like moving towards more towards an AI, but NLP is a different domain. But with the help of an AI related things, now the NLP is trying to move towards an AI centric one. So and they are trying to solve the problem in a most efficient fashion. So now we will move into the uh, we move into the next part, like what are the libraries frameworks which we trying to, like not only we most of us is trying to use in the industry. If you take two different things, one is Python and another is R. So people nowadays is not using an R the most, like in industries. So in Python we will be using an NLTK is natural language toolkit. Another one is a spacey. We have a framework like PyTorch and TensorFlow for the deep neural architectures. And you have open source contribution platform such as an Hugging Face, where your deep learning models will be uploaded. You can directly fetch from the Hugging Face and you can use for your own use cases. And there's something called Jensen. So in this course, we'll try to focus on NLTK and Spacey, not Jensen. We'll give some materials related to Jensen also. Like if we go into the neural network architecture, we try to use TensorFlow. And if you move into the LLM kind of one or LLM, any deep learning architecture, we'll try to extract some model from Hugging Face. So this is the frameworks and libraries for an NLP. Now we'll move into the NLP pipeline. Okay, so we are going to the first step of the process, that is an NLP pipeline. Okay, what is an NLP pipeline? Okay, let us say I am building some project. So in the building some project, there should be certain ways I need to follow in order to build my project, right? So there are those kind of ways or those kind of steps which is going to involve in building some of the NLP project, is what they mean as an NLP pipeline. So NLP pipeline refer to the sequence of process or the steps which we are going to apply in order to extract the pieceful of information related to natural language understanding. For example, if I want to build certain amount of model, I need to follow certain amount of steps in order to build those kind of models. In order to build those kind of steps is called as an NLP pipeline. So we are a 7-step process in NLP pipeline. First one is a data gathering. So next one is a text cleaning, and another one is a text pre-processing. Fourth one is a feature engineering. Fifth one is like a model building, and sixth one is like a model evaluation, and seventh one is a deployment. We will see in detail what this actually each and every step is actually means. Okay, so first one is a data gathering. So data gathering, okay, let us say I need to build some model, like I need to build some NLP model. In order to build some NLP model, I need a data, right? Because without data I cannot able to build anything out of it. I need a data because data provides me an experience, or data provides me some amount of knowledge base. I need certain amount of data. Okay, next thing, you need a data. Where to collect the data? Okay, there are two ways in which you can collect the data. One is your first party data. What is meant by first party data? So if you're working in any organization, the organization itself is having a certain amount of data. For example, let us say I'm working in some fintech company. If I am working in fintech company, let us say I am going to predict whether this particular customer is a fraud customer or not fraudulent customer. In order to predict those kind of things, I have my own set of data. So while I using my model, I'm using my own set of data in order to build my model. Those kind of data is called as first party data. So first party data is nothing but whatever data which is available for your organization and it's allows to use, that is called as a first party data. And the next set of data is like open source kind of things. So in the open source kind of things, you will have a public data set. So if you want to get any public data set, you have a Kaggle. So you can go to Kaggle and you can fetch the data from there. Not only Kaggle, you have a a different set of open source platform where you can get your data set in order to build your NLP project. So to get the data set, you need to know what problem you are going to working on, right? So based on the problem, you can able to search for the problem and you can get the data set in the open source as well. Not only Kaggle, there is something called as Open Hugging Face. Like Hugging Face is an open source platform where you can also get the data set related to the your NLP problem. So that is a public data set. Next one is like a web scraping. Okay, let us say I need to scrap some of the details from the website. Let us say I'm building some chatbot. Okay, so if I need to build some chatbot that is related to specific use case, let us say I need to build a chatbot for SNH Chennai. So if I need to build a chatbot for SNH Chennai, I don't get a data set which is publicly available. I need to scrap those kind of contents from my website. So in order to scrap those kind of contents from the website, you will be having something called as BS4 Beautiful Soup, HTML parser. Those kind of libraries and packages will be helping you to get those kind of things in a web scraping techniques. Next one is like I need to extract some details from the images. Okay, let us say I have a huge amount of images. That images will have some amount of data. I need to extract text from the images. How can I do that? You have an option called OCR. OCR is optical character recognition. With the help of OCR, you can able to extract the text from the following images. Okay, let us say I have my data set as a PDF kind of things. I have a bunch of PDF. Okay, so from the bunch of PDFs, how can I able to extract my kind of text or prepare my own data? Okay, that is something called as PyPDF2. So PyPDF2 is a package which is going to help you to convert all your PDF material into the raw text data. So you can use your package PyPDF2 to extract the data from PDF text. So next one is like a data augmentation. This is not actually data gathering, sorry. So data augmentation is like nothing but, let us say I have a less amount of data, okay, but my model is always need a huge amount of data to build. For example, if you take any deep learning architecture models, that will need a huge amount of data. At this case, I need to go for an augmentation technique. Augmentation techniques involves like adding some amount of extra data to the model, which is not actually the original data. It's a synthetic data creation. So there is a certain amount of techniques called noise injection. Okay, just leave it. We don't need this kind of things right now. So there is another technique called data augmentation. So this is the first step in our NLP pipeline. One is like data gathering. I'm just giving a summary of the whatever you see in the data gathering thing. If you, we need to pick an NLP problem statement. Based on the NLP problem statement, we need to look for the data set. Okay, how can we look for the data set? There is a two ways of looking for the data set. One is like a first party website, and another one is like a for second party, like a third party kind of thing. So first party data is nothing but the data which is used in your own organization is a first party data, and open source data is like what we are getting outside the internet. What we are getting from an internet is an open source data. So open source data, there is a two platform to get your open source data. One is a Kaggle kind of thing. Another one is like an Hugging Face. There is a multiple things. So we stick with the Kaggle and Hugging Face to extract those kind of data. And there is a different techniques and packages which are available for the different use cases. For example, if I have a data in my PDF format, I need to convert into the text. I can use a PyPDF too. If I have an image, I have OCR techniques. If I have in a website, I have Beautiful Soup or any other function to extract those kind of details. Okay, so this is what we do in a first step of an NLP pipeline. Usually in an industry, so these kind of data need to be validated by your project managers or your higher level officials, because with their approval only you can move to the next step of the pipeline. So you need to get an approval from your head or any manager or kind of thing. So this data gathering is really important, because this is a base or knowledge base for an NLP model. You need to work it out in order to get your most set of relevant data. How you can select the best set of data? The best set of data is going to get by using a trial and error method. You're going to work on different set of data, and you're going to find which is the best kind of one for the particular model. So next step in the pipeline is a text cleaning. Okay, so whatever data you're getting is not clean. Not clean in the sense those kind of data will have some amount of an punctuation, some amount of an HTML tags. As even if you scrap the data from the website, those kind of things contain HTML tags, and you have spelling mistakes, and you have a certain amount of a special character, and you also have some characters which cannot be recognizable. Let us say underscore slash x and 1 to 3, and those kind of data is not unrecognizable. So those kind of data we need to clean before feeding into the model or before we moving into the next step, right? So there is something called as text cleaning. Okay, so text cleaning involves removing the punctuation. So I don't need the punctuations in my data, and I need to remove the numbers which I don't really need for the modeling kind of things. And I need to remove the white spaces. If I have huge amount of white spaces, that's going to carry some amount of an computation. I need to remove the extra spaces, and I need to remove emojis. Okay, so in the next session we are going to see how emojis can be mapped into the characters, because there is a different kind of an emojis which is going to give a different set of an meaning to the text or meaning to the context, right? So we are going to see there is a certain package, or there is some function or script which is going to convert your emojis into the numbers, emojis into the representation, you can say. Okay, so another one is like remove the contradiction. So let us say I have a word, right? So which is going to represent as an $100, like DOLS, and another one is like $100. The dollar is in symbol location. I need to standardize those kind of text. So that is a text cleaning kind of things, or else I will remove based on the guidelines which is going to follow. So this is what the text cleaning. In the text cleaning, it's very we need to clean our old text kind of things. We need to use a regex. So regex is like a packages where you'll be using to remove those kind of text, those kind of things. There is a script which is available predefinitely to remove the HTML tags or any special characters kind of things. And it's a pre-processing. Okay, so the goal of the pre-processing is like I need to enhance my data. So one process is a text cleaning. Okay, I can clean up to certain extent, right? After cleaning, I need to enhance my text. So in order to enhance my text, there are some different ways of doing. There's like a 6 ways of doing. First one is a tokenization. Okay, we'll see in detail what these steps actually mean. Second one is a lower casing, and third one is like a stop words and punctual removal, and fourth one is a normalization, and fifth one is a stemming, and sixth one is a lemmatization. We will be seeing why stemming is not useful. We are going for a lemmatization also. So now we look into the what is meant by tokenization. Okay, so the tokenization is nothing but in NLP we are going to focus only on tokens. Okay, what is meant by tokens? So I have a text like I love my cat. I'm going to break this text into individual tokens or individual words. So this particular individual words or chunks is called as a tokens. So this is going to be I, comma love, comma my, comma cat. So each and every word is called as token. So I will always use to process tokens in my NLP. So I need to break down my text into the individual chunks or individual tokens. So this process in first step in text pre-processing called tokenization. You're going to break down the piece of text into the individual character, or it may be depend on two or three or chunks, like two or three or words together. So the basically it's called as chunking. So we are going to so not chunking. we are we are going to divide into smaller chunks called tokens. Like in this case, there is a one word. I is a one token, love is my one token, my is one token, and dog is another token. So this is what we call as a tokenization. So next one is like lower casing. Okay, what is my lower casing? Like we have different words. Like in the feature representation part, like we're going to see in the next class called feature representation, how we are going to represent the text in the form of numbers. So if you're going to represent the text in the form of numbers, your smaller case variable and your capital case variable like is going to have a different kind of meanings, right? So we are going to lower case in order to produce a standardized form. So that is also another typo here. So don't consider this thing gold kind of things. So you're going to lower case. So next one is like stop word removal. What is my stop word removal? What are the words which is going to occur most frequently in your vocabulary? So those kind of words we will be calling as stop words. So the particular stop words, because the ML model or any model is going to give a importance to the word which is less occurring, because less occurring words is going to give a huge amount of an importance. So you're going to remove all your stop words. So the word which is going to occur many times and doesn't add any real meaning to it. So those kind of words we will call as a stop words, and we'll be removing some amount of punctuations, because punctuation doesn't matter really in case of modeling techniques. So we'll see a code like not only the theory session is going to happen today, we'll also see the hands-on session, like how the each and every step is going to happen. Well, let me finish these kind of theory things, like concept things. Once I started finishing those kind of concept things, we'll go into the hands-on session for the coding kind of things. Like we'll work on hands-on text pre-processing project for the project like we call it as a spam classification. Okay, we'll start with spam classification today. So next step in the text pre-processing is a normalization, as I said earlier. So I need to standardize the text. Okay, so I need to standardize the text into the single canonical forms. For example, if you see the if you see the following diagram, this is the $100 and this is $100. Okay, so I need to convert into the single standardized form, because these two giving me a same meaning, right? So if I need to represent these two words in the feature representation, so it's going to give a different like different meaning, but I don't need a different meaning for the same word. So that is why I need to reduce into the single canonical form. So this process of reducing into the single canonical form or standardizing the text, which we call as a normalization kind of things. So in this case, I have a certain amount of library functions or external library functions or heuristics which I can use in order to convert my text into a standard form. So the next one is like a stemming kind of thing. So stemming kind of thing is basically going to reduce your word into the root word or base word. For example, if you have something called as developing and development, so these two words is going to reduce into this base word or root word called develop, right? So this is called as stemming. So there is a drawback in stemming, right? So what is the drawback in stemming is actually means, like there is something called argument and arguing. There are two words called argument and arguing. If I stem together, that is going to give me argue, argu, which doesn't have any real sense of meaning, right? So I need to have something which is going to give me the base or root word which conveys some meaning. So the stemming will not able to convey some meaning to it. So I don't use stemming really at all. So that is why the people in the people started working on lemmatization. So what is lemmatization? Though basically the lemmatization is like it's going to give it in the root word or base word that is going to have a real meaning, or that carries some amount of real meaning or real context to the word. So for example, in this case, if you just see charge and charging and changer, so it's going to give it as a change as a root word. How it's trying to do? Because lemmatization, how it's trying to do? Because we need to know, right? So stemming cannot do how lemmatization is trying to do. So the lemmatization is trying to do by using something called predefined predefined dictionary. We are done with the text representation. Okay, now we are moving into to something called feature representation. What is meant by feature representation? Okay, if you're building any machine learning model or any deep learning model or any architecture kind of models, the model doesn't understand the words, the model doesn't understand your language, the model will only understand your numbers, model will understand only zeros and one, right? So we need to represent everything in a form of a numerical representation. So the process of converting your word or raw text into the numerical features or numerical representation, which can you give an input to the machine learning model, is called feature representation. Okay, there are two ways of doing a feature representation. One is called as a traditional methods, which are used in the olden days, and not only olden days. Now only we are now also we are using some of the techniques. And another one is like a neural based approach. Like neural based approach is nothing but a kind of deep learning architecture approach for building your feature representation. Don't worry if you don't understand. We'll try to look in detail in the next class with the hands-on coding session. So in this traditional approach things, we have four things. One is a one-not encoding, bag of words, n-grams, and TF-IDF. TF-IDF stands for term frequency, inverse document frequency, and as a neural approach, you'll be having a pre-trained model. So we have Glove, fast text, word to vex. These are the models which is going to produce an embeddings kind of things or any feature representation. Next one is a SIBO, and another one is a skipgram. Okay, all these techniques, what is going to do is if you give a text, it's going to convert it into mathematical form. For example, if I'm going to say SNSC coding club, if I give those kind of tokens or if I'm going to give the toast amount of raw text, it's going to convert into some numbers based on the embedding techniques which we are going to solve. So in the next class, what we are going to do is we are going to have an hands-on session on each and every method, how each and every method works, and we have each and every algorithm for each and every method. So we will try to explore how these kind of things are working. So today's point is like we need to understand what is text pre-processing techniques, and we need to work it on a hands-on thing for the text pre-processing techniques. Now we are moving to the next step in the pipeline called model building. Okay, let us say, okay, fine, we start data gathering and we normalize the text and we standardize the text and we did all the text pre-processing step. After doing the text pre-processing step, I converted it into some feature by using some techniques. Okay, I have numbers right now. Okay, how to build a model with the numbers? Okay, so I have a huge amount of data set. The data set is converted in the number, that is feature representation is done. I have a huge amount of data set with the numbers. Now how I'm going to build a model. What are the ways in which I can build a model? Okay, there are two different ways in which you can build a model. This is particularly with your what problem you're trying to work on. In some cases, really your machine learning model will outperform your deep learning model. There are some cases where the industry is nowadays is even using a logistic regression to sticking on instead of going some of the deep learning architecture. That basically depends on the problem which you are trying to work it on. Like for the machine learning model, you have a logistic regression, you have an A-base, and you have a SVM kind of things. For a deep learning kind of a model approach or architecture approach, you have a recurrent neural network or long-term short-term memory and your transformer, BERT, those kind of techniques. Okay, now what we are trying to do is like we in this following 7 days NLP session in the machine learning model, we are going to see logistic regression, and in deep learning model, we are trying to see RNN as well as transformer as well as BERT and LLMs. So these are the things, the models which we are going to work it on. For the extra hands-on material, we trying to give it as a NA based and SVM, like the code as well as explanation for those kind of modeling techniques. Your assignments will also based on whatever we did in class or whatever we did in session. So don't worry. So these are the ways in which you build the model. Okay, let us say I build the model. And how can I improve the model and how can I evaluate the model? There should be some techniques. No, that particular techniques is going to evaluate my model, right? So there are different kind of techniques. Okay, let us say I'm working on a problem called classification. So those classification problem, let us take another example of a spam classification. Spam classification is going to have a two set of label. One is a spam, another is a ham. So I need to classify, my model is going to classify either it's a 0 or 1. 0 means it's a spam or 1 means it's an ham. Okay, so how do I evaluate my model? This problem will come under the category of classification. So I need to talk about accuracy, I need to talk about precision, I need to talk about recall, I need to talk about F1 score, I need to talk about area under the curve. So these are the different metrics which I be using in order to for my classification problem. Next one is like a sequence labeling problem. Okay, let us say I have a sequence labeling. So for the sequence labeling problem, I will be looking into the F1 score. Don't worry, if you don't really understand, we'll try to look on the problem statement which you're trying to work on during the session. So the next one is like a information retrieval. So if you're working on any information retrieval system, IR system, so I will be looking on an MRP, MRR and MAP. These kind of metrics I will be looking on. If I'm looking on working on a text summarization kind of things, I will be looking for a blue score. I will be looking for log metrics and different kind of metrics. If you're working on a regression problem, I think most of it done in a like machine learning kind of thing regression. So for that, you'll be looking as an RMSE, like root mean square and mean absolute percentage error. You will also look on MSC, mean square error. So these are the different evaluation metrics which you're trying to benchmark your model. Let us say there's a two different candidates in your company or in your college who is working on a same problem statement. How you can say that one model outperforms another model? You can say one model outperform another one using this evaluation metrics. So you will always need to remember on your evaluation metrics. So just in case, like one key point, if you using a data, that particular data is like an unbalanced data set. Okay, what is meant by unbalanced data set? Unbalanced data set is something in which the labels or the distribution of a labels is not assigned properly. For example, let us take the problem of a spam classification. So if you're working on a spam excuse me, if you're working on a spam classification problem, I'm going to have two label. One is a spam, another is an am. Always try to look at data set which is having equal distribution. If not equal distribution, you have some algorithm like oversampling techniques and undersampling techniques. Those kind of techniques will make the balanced data set. So always try to work with a balanced data set, because if you're working with a balanced data set in which you can even compare your accuracy, because balanced data set produces a good amount of an accuracy. Like For example, if you're working on an imbalanced data set, your accuracy even more higher, even though your model is performing worst. So those kind of problems will be you can expect in the future cases if you're working on an imbalanced data set. So there are some techniques, such as oversampling technique, undersampling technique. You have smoke techniques, and near mist algorithm. So there is a different kind of an algorithm which you can explore on it. Okay, so fine. If my algorithm, okay, all perfect right now. Now I build the model and I test it to the model in the local systems, like local production systems, like within my organization. But if I building some business or I need to incorporate some business logic, right? I need to make my model which is available for my public, or if I need to make my model available for my different colleagues or different peers, what can I do? I can go for the deployment phase. So in the deployment phase, what we are trying to do, we are going to build whatever model we are going to build, and whatever the model we are actually build, we are going to deploy the model to the cloud or some cloud. So after building to the cloud, what we're going to do, we are going to create an endpoint, and creating an endpoint. After creating endpoints, I'm going to access to the everyone in the organization or everyone in the surroundings or everyone in the internet. So those kind of things will come under deployment. We are going to give you one beautiful project source code for the deployment kind of things, a full end-to-end deployment in Streamlit, or you can have, you think of a different deployment platform, Airku. There is a different kind of deployment platforms is there. You can explore those kind of deployment platforms, right? So this is under the deployment. So these are the 7 steps which you're going to focus on an NLP pipeline. In today's session, so for the coding part, we are going to focus on text pre-processing. Like we'll have a data set. That data set, we are trying to clean the data set, and we are going to involve all the text pre-processing, tokenization, stemming, lemmatization, lower casing, and we'll also use something called as word cloud in order to visualize our text. So with that, we'll bind the class. Now we'll move into the coding session for the text pre-processing steps. You can also code along with me. Everyone, before that, just log into the Google Cloud. So with the Google Cloud, yeah, you collab, you have a collab account, right? So try to log into the collab notebook. Once you download the file, just you go to the Google Colab and create a new notebook. So after creating a new notebook, you have something called as file sections. So in the file section, you try to upload the session story. That is your file, whatever the file you downloaded right now. So you have this file. So this is a big name. So let me rename to spam. Okay. So initially, what we're trying to do is we will import the packages. So what are the packages we need? Basically, we need NumPy. There is a numerical Python for numerical operations. So then we need a pandas kind of things. So what the pandas is like a data frame operation, whatever the file you need to have a pandas library, pandas package. So next one is like I need to do some amount of visualization kind of things. I can go for the matplotlib. Pyplot, we just include PLT. So the next one is like we have something called as NLTK. What is NLTK? NLTK is something called as natural language toolkit. We imported NLTK, right? So natural language toolkit. So after importing NLTK, we are mostly working on strings, right? So we'll import string package also as something observation history. Then I need something called regex. So I import regex for pattern matching. So if we want to import any packages in future, we will come here and we'll import that, no problem. So now if you import NLTK, right? So you need to download 2 packages in NLTK. Like you have something called as NLTK.download. So one is your stopwords. So you need to download your stopwords. And next one is like you need to download something called as WordNet, which will be used for your lemmatization operations. So WordNet. So yeah, perfect. So now what I'm going to do is I'm going to read my data. Imagine you already gathered the data from somewhere. So now you're going to read the data. So in order to read the data, you can use a pandas function. So pandas function to read your data is like pandas dot, for example, in this case, I use PD. So PD dot read underscore CSV. So then you put your file name. So in my case, it's spam.csv. So after reading your data, it will be a data frame object. So you put data and you can see. So you can see your data. The data has 2 features. That is 2 columns. One is categories and another one is messages. So if you want to know more about the data, like if in this case it's easy, right? We have only 2 columns and we have only 5572 rows. But in case what happen, you have a 30 or 40 records. So you can use this line, which is called as data.info. So this particular thing is going to give you the information about your data frame which you have loaded by using a CSV file. So you can get that you have a 2 column or 2 feature. One is a category and another one is like a messages. So message is going to what are the messages, and you have a respected labels like what is, whether it's going to be a ham or spam. For example, let us take the spam category, that is index 2, right? So let me take data of message. and index 2. This probably going to give free entry into weekly come to Fin FA World Cup Finals 2020 or 2005, right? So these are some spam messages. So and the corresponding label is spam. Okay, now we need to visualize. First, then we need to visualize whether the data is going to contain some imbalance kind of things, right? So you can do something called value counts. So what does value count is actually means? So value count is going to give you how the distribution of the labels is according how the label is distributed according to your data. For example, you use category, right? In this case, category is here spam and app. So you can put your methods called value counts. So this value counts is going to give you like how many labels are classified as spam and how many labels are classified as ham. In this case, only 744 as a spam and 4825 as an ham. Okay. So now it is a kind of an imbalanced data set. For any machine learning model building, you try to use some oversampling or undersampling techniques. That is the best practice. But now we are not going to do into the any algorithm part, right? So we better leave it. So if you want to plot kind of things, you use this statement like you put plot dot plot, and you need to mention what kind of plot you are going to put. Let us say I'm going to put a bar plot. So this is going to give me a bar plot. So like a pictorial representation kind of things. Now okay, so first step in the process is like I need to remove the punctuations. Okay, so I cannot able to remove the punctuations like every time, right? So what I'm going to do is I have a built-in function. So we have string, right? We import a string as st, right? So string has something called as punctuation. Okay, fine. Okay, let us say you don't know what is available in string. So there is some shortcut in Python which is called as bar. So if you put bar and you put st, the string object, right? So it's going to give all the methods which are available in string. So in this case, there is different methods like ASCII letters, ASCII lowercase, uppercase, capwords, digits, hexadecimal, printable punctuation spaces. What we need a punctuations, right? So you just put st dot and the method name. Method name is a punctuations. So you can copy from here and you can paste it. So this is what we need a punctuation. So these things I need to remove in my message, like in my feature, in my text. Okay, so that is the first step in the text pre-processing. I need to remove my punctuations. Okay, so how can I do? I need to write one helper function. So helper function, let us say I write one helper function. That is helper function is nothing but a small function. So the function name is like we can give remove punctuations. So small thing. So we need to give a text as an input. So we just put one thing called CLT. CLT is nothing but like I give a variable name as a clear text. So for each and every or I in text, so if I in not in, let us say if I not in st dot punctuations, I'm going to return it. I'm going to add it. Am I going to do CLT plus equal to I? I will return CLT. So this is a basic function which is going to remove all your punctuations in the following text. For example, let us say I'm giving you a use case like I call this function remove punctuation PNC, which we wrote, right? So in this, I will giving you one test case like SNUC underscore C coding club hashtag 12 at NLP. So we'll see how it performing. See, it remove all the punctuations, right? So we are good to go. Our functions really work well. So I need to apply this function to my data set, right? I need to apply this function to my data set, like a data feature, like the feature called message. I need to apply to the whole data frame. What am I going to do? You have a simple method called apply. Okay, fine. You don't know this thing, right? You have something called as bar. So you put the data frame, like the data is a data frame object which containing, right? You put data means you get all the methods which are available in the data. So you see, we are going to use something called as apply. So what is apply? Apply is going to do, right? So you just put data of clear text, or you can say you're going to create a new feature. Let us say we say first process, no CLT1. We give any name. It's up to you. You can give any name. Let us say I exit clear text one. So I'm giving CLT1. So what I'm going to do, data of message, right? So message I have a function called dot apply. Dot apply is going to take an argument as a function. So what function we are going to give? We are going to give a function as remove punctuations. So that is a function we wrote here, right? So that particular function, I'm going to give it as an argument to the apply method. So this thing is going to remove all my punctuations in the message column. I'm going to give as a new data called data of CLT. So if you see the data frame, we will be having another feature called CLT1. So this CLT is going to remove all your punctuations and all your punctuation marks in your data set. So this is CLT1. So we are done with the first process. The first process is like I need to remove all the I need to remove all the punctuation. So if you want to test it out, let us take the first row of the message thing. Okay. If you take the first row or first record, so you just print it out. So in this text, you see there is something called dot dot, and there is a three dot dot, and there is also a three dot dot, right? So we'll see what is the result after we apply the remove punctuation function. Let us say we do CP1, right? So in here you put 0, like the first record, you see. So we remove all the punctuation kind of thing. So this applies to all the records in the data frame. So this is step one. We are done with the step one. Now we are going to move into the step one. Okay. So the step two is like I need to lowercase and I need to tokenize it. So what is tokenization? Tokenization is a process of breaking down the words into the individual words or individual tokens. Right? So we are going to do a tokenization. So tokenization munadi, what we are going to do is we need to lowercase it, right? So you can easily lowercase. For example, SNUC coding club. So this is the text which you need to lowercase. You have a simple function dot lower. So this particular function will give you the lowercase version of your text. So you can use dot lower, which is a string function. So you can lowercase it. And let us say I need to divide each and every words. Okay, fine. Let us say this my text is going to be hi, welcome to the NLP course. Okay. I need to break down into the individual words or individual token. How can I do? I can easily do by using something called I give the variable name as token. So I'm going to use a regex. Regex I'm going to use a split function. So in the split function, what I'm going to give is slash s plus. It's going to remove the like each and every word space. It's going to give it as a individual words. I'm going to split it as a individual words. So re dot split. Then I need to give another argument as a text. On which text I'm going to operate. Like my variable name is text. So if I try to display the tokens, you can see it's going to be hi, hello to the NLP course. We did it as individual tokens. Okay, we need to put all together as a single function, and we give the helper function name as tokenize. So whatever we did above, we are going to give the name for the tokenize, and text is going to pass as an input. First thing I'm going to do is I'm going to lowercase. So text dot lower. So it's a lowercasing version. Then I need to create a list and I need to tokens. So tokens is nothing but re dot split of your slash s plus comma going to be your text, and I'm returning the tokens. So this is my helper function. So we'll test it on some use case, like on test case. You take the data of CLT underscore one of 0. So this is nothing but so this is the data which we are going to give to test our function. This is go until during point crazy available only in bugs and grade blah blah blah. So if we give a function into the tokenize, it's going to give it as individual tokens. So okay, fine, this worked perfectly well. I need to apply for the entire data set. Okay, so for the interpretability, what I'm going to do is I'm going to create another column or another feature called tokens. So tokens is going to be your data of CLT1. I'm going to apply in a cleaned version, like cleaned text dot apply of your tokenize. So this is the function which you're going to apply. Okay, fine, it's perfect. So if you see a data frame, it's going to have the 4 features now. One is category, message, CLT1, and tokens. Perfect. Okay, so we are done with the next step. Next step, what we are going to do in the process is I need to remove all the stop words, right? So if you want to remove all the stop words, okay, let me show you something related to NLTK. So natural language toolkit. So from nltk.corpus, you have stop words. Import stop words. Yeah, I guess it should be perfect. Okay, it's perfect. Okay, so from nltk.corpus you input stop words, and what are the languages NLTK support as right now? So you can see like stop words, like NLTK is only limited to certain language, only English, Arabic, I think Chinese is available, German is available, Greek is available, maybe Spanish is also available, but I'm not sure. So NLTK is supported only with certain things. So let us say what are the languages here supported. We'll see. If you put a field IDs, so you can see what are the languages NLTK support of. Like stopwatch is available in Arabic, so Chinese, Danish, Dutch, English, French, German. Yeah, German is there. Like Italian is there, Portuguese, Romanian, Russian, Spanish, Swedish, Turkish. So these are the stopwatches which are available. But we need only English, right? So we take only English. So we put this functions like a stopwatch from stopwords.words. I'm going to take only English. So you just give the language name. So I'm giving English. So you can see these are the stop words in English. So I need to remove all the stop words. So like I need to remove one, I need to write one helper function. So that helper function is going to remove the stop words from my token, right? So I give the name of the helper function as remove stop words. So inside this, I will be giving my tokens. So in here, I use a list complication. So list complication basically says the token is what I'm going to return. So for token in tokens, if token not in we give 1 second, we give stp underscore words, you store it in the variable, or you also can able, you also give it like this also, it's never mind. So not in st.stopwords. So this is going to return. Okay, if you want to test it out, let us say we'll test it with some tokens, right? Okay, we put so these are some tokens. Okay, so we test it out with this token. So test is a variable tokens. Okay, remove stop words. In the remove stop words, I'm giving as a test. So in this case, is and this is and as should be removed. Yeah, exactly. So if you look at this particular is and as has been removed because that is considered as a stop words. So fine. So perfectly fine. But we need to apply for the entire data frame, right? So you can put it as data of tokens itself. Like I updated my tokens feature itself because we already have tokens, right? Here. So in the token itself, we apply the stop words kind of things. So data of tokens, you put another data of tokens dot apply, and you give your function that is a remove underscore stop words. Yeah, so probably it will take around 5 to 6 seconds. We'll wait. Yeah, perfectly fine. Okay, so now what I'm going to do is I'm going to do something called a stemming and lemmatization. Okay, how can I do stemming and lemmatization? You need to import these two packages, like you import these two methods. So from NLTK, you just import something called port stemmer. Port stemmer. It should be correct. Okay, fine. Okay, sorry, that is porter. Yeah. So from NLTK, import port stemmer. Okay, if you want to know what are the methods which are available in port stemmer, you just put DAR. After DAR, you just type porter stemmer, and you can see the methods which are available in port stemmer. We are going to use only stem because we need to get stemming, right? So we're going to use only stem. So now, if you just call it into the object called porter stemmer into the PS variable, so porter stemmer. Now it is easy for us. Let us say, let us take this example. Okay, running. So if I take this example running, so I'm going to stem it ps.stem of test. It's going to give me the result of run, right? Yeah, exactly. So I need to write one helper function to do this task in a defined manner. So let me give the name of the helper function as stemming. So inside I will give tokens. So what I'm going to do, I'm going to create an object called port stemmer. So then what I'm going to do, I'm going to return. I'm going to use a list complication again. So ps.stem of token. So next is like for token in tokens. So for each and every tokens which are going to take place, right? Okay, fine. So for each and every tokens, go until, during, point, crazy available for each and every word or each and every token, I need to get the stem word. So that is why I'm using a list complication ps.stem of token for token in tokens. So if I run this program, okay, fine. So okay, let us say we tested with something. Okay, let us give the name of tokens, or okay, fine, we give it test. We use the same variable. My name is Muthu, so this cannot be stemmed. So we have cooking, something called as fishing. So now you just apply a stemming function and you just give a test. You will get Muthu cook fish. Okay. So these are something which you can get as a tokens. Now you need to have like a kind of things. Now we need to put it together in a helper function. You already put it as a stemming. Now you need to apply to your data frame, right? So what you can do is you can create a new feature called stem tokens. Like you can give your names according to your observation. I'm giving as a stem token. So I'm going to apply for the tokens features. Yeah, we have tokens, right? Yes, exactly. The tokens. So in here, you just give it tokens dot apply of your stemming as an helper function. So for example, I need to test it with some random data. So tokens of, let us take the ninth record. PC mobile until, in this case, can you guys note? Okay, fine. Let me show the normal version, like normal tokens. In this case, there is something called mobile, and in that you have the update. Inge you have your mobile, and you have your update. UPDAT doesn't have any meaning, right? It doesn't have any meaning. So stemming is like a shit kind of thing. Okay, I don't need a stemming. I need to go for a lemmatization. Okay, how can I go for a lemmatization? So that is why the people is not using stemming, because stemming produces some words which do not carry any real meaning. So we go for a lemmatization. How am I going to use lemmatization? For stemming, we use something called as stemmer, right? So for lemmatization, we will be using something called as word net lemmatizer. So from same NLTK, you're going to import word net lematizer. Okay. So yeah, perfect. So let us say I don't know what are the function which is available in the word net lemmatizer. I put dir, and dir I need to give an object as word net lematizer. So this particular thing is going to give me all the methods available in the lematizer. I'm going to use only lemmatize because that is what I need. So you just use the lemmatize. So in there, what you're trying to do. So for example, for that case, we use piece, right? For there, we use word net or any variable. You just call the object word net lematizer. So here now what we are going to do. So for example, let us see. Here in stemming, you have something called as mobile, right? But it produces as an, sorry, here I have mobile, but it produces an mobile. So we test the same thing with the lemmatizer. So you use word net and you call the method. What is the method name? Method name is lemmatize. So word net dot lemmatize, and you just give mobile. You see the result, it's going to produce as a mobile. But if you use stemming, ps.stem of same mobile, it's going to give mobile. So there's some difference, right? So that is why we're going for a word net, like a lemmatizer. Okay, I need to wrap it in a helper function. So what I'm going to do, I'm going to write one helper function. That helper function named as, let me keep a simple name like lema. So and I give the tokens, sorry, tokens. Okay, so I import the word net as calling the object word net lema tizer. Then I use the same word comprehension to reduce the complexity. So word net is what, where is it? Okay, fine. Word net dot lema ties of token for token in tokens. For each and every word I need to calculate it, right? So that is why I need for token in tokens. So we'll test it with something lema of data of tokens of 9th record. Perfect. So now we create one new column. For that column, what we named as stem tokens, right? So we put lema tokens. So we put lema tokens equal to data of tokens. So dot apply, you just put the name as lema function name. So you see lema tokens. So now if you see your data frame, you have multiple features. So this is the first bay raw form, and we have some improved form. CLT1 is a remote punctuation things. Then we converted it into tokens. Then we use a stemming. Then we converted it to the lema tokens. Okay. Finally, I ended with the lema tokens. So from lema tokens, I need to convert the text back again. Like from lema, I need to convert the text back again. So I just join all the words together in lemmatized, and we call it as a pre. If I write the helper function, so the helper function I name it as like return sequence and tokens. This is going to return me a sequence. Okay, so just a simple thing. My bad. I'm going to return some space and I'm going to join. What am I going to join? I'm going to join each and every token in tokens for token in tokens. Perfect. See, let us give an example for the return sequence. Data of lema tokens of 9 to get the perfect thing. So if you see the normal text, like without pre-processed text, so it is something like this, but after pre-processing we converted to these things. So that is what the pre-processing is actually like all about. We just remove some of the unwanted details and we convert it as a pre-process kind of things. Okay, fine. So I need to convert for all the things. So what I'm going to do, I'm going to create a new feature called pre-processed text, like pre-process text, so which is going to be data of apply for the Lima token, guys. Lima tokens dot apply of your things. So what is the function name? Return sequence. Yeah, fine. Now if you see a data, it's going to be a cleaned kind of things. So you have a clean kind of things. That is a pre-processed text. Okay. So fine, we are good to go now. Okay, fine. So this is what the text pre-processing is all about. As an extra content, what I'm trying to do is I'm going to wrap it soon. Okay, don't worry. So as an extra content, I'm going to give you one code, like one script, which is going to generate the word cloud. What is word cloud? Word cloud is what are the words which are present in text. I'm going to visualize the word, like based on the whatever higher repetition. What are the words which are repeated more? So that is what we are going to do. So that is called word cloud. So to word cloud, what I'm going to do is I'm going to generate a word cloud. So to generate word cloud, just I need to add this following script, word cloud. So from word cloud, you just import word cloud. This W will be capital, this method. Yeah, exactly. Word cloud. And I need to generate in an image color generator. So you just import image color generator. I should import it works perfectly fine. Yes, perfect. So now what I'm going to do is let us say what are the words which are most frequently occurring in a spam message. So to filter the spam message, I'm going to use this technique called Boolean indexing. So in here you just put the category, and in the category you just take spam. Okay, let me show the data results. So this is going to contain only the categories which is spam. Okay. This is going to excuse me. Uh, this is going to contain only the data which is spam kind of things. Okay, so let us take the spam kind of thing, and I'm going to visualize what are the texts which are most frequently occurring in the spam. Okay, for that you just join every words together. So given for x in results. Okay, so results of, we did write pre-processed text. Where is that? Pre-processed text. Okay, so this contain all the text together. So now I'm creating a word cloud, just a simple line of creating a word cloud. You can also work it with it simultaneously. You just call the word cloud, the method. Inside the word cloud, you need to give your font size. What are the max font size you need? So I'm giving the max font size as, let us take as 40. um, Next, just maximum words which I need to have in the pictures, let us give as 1,000. You can give it on your own. So okay, then you need to use the function called generate. So this generate is going to take your text txt. Okay. Now your word cloud is ready. So this is going to be as a word cloud object. I need to plot it using a matplotlib. Okay. So before matplotlib, I need to display the configuration of a matplot. So let us say plt.figure. So plt.figure, I'm going to use the figure size as, let us say, 25 comma 10. Then plt.imshow. Imshow is going to display your image. That is a word cloud. Okay, that's a type of word cloud. Never mind. So you just off the access because that is without a good one. So you just off your access. Then you put plt.show. I hope it should work. Yes. See guys, in this things, what is happening, right? So this is going to give you the maximum number of words which is available in the spam kind of thing. See, contact you, please call, text, orange claim, landline, chat, club, chance win, price guaranteed, so stop, tune, 150p, urgent, offer. So these are considered as a spam kind of things. Okay, now we run it for a ham, not a spam. So we run for an ham. So same kind of things. So you just put. Now we'll see what is coming for an ham kind of things. So really, friend, hey, come, thank, good, night, okay, life, no, later, already, today, and blah blah blah. Okay, guys. So these are the word cloud representation. You can use it as a visualization kind of things to see how the words are distributed in the two categories. So we'll try to share this notebook as a repo kind of things after proper documentation. So you can expect this within tonight. So as a repo, as well as we will also try to upload the day one slides materials and also extra things like the blocks and the we own notes materials and we extra things which we need like how the lemmatization part works as extra things we will try to upload in the Notion page.